Hello everyone, myself Karthik S, working as Assistant Professor in Hindustan College of Engineering and Technology. In this video, we'll discuss about the topic types of schedule in DBMS. So in this video, we are going to discuss about the basic definition of a schedule. We'll discuss about conflict schedule, serial and non-serial schedule. We'll discuss about conflict serializable schedule and conflict equivalent schedule. Further, we'll go with recoverable and non-recoverable schedule. Then we'll discuss about cascade schedule, and finally we'll move on with strict schedule. First, let us move on with the definition of the schedule. A schedule is a sequence of instructions that specify the chronological order in which the instructions of concurrent transactions are executed. A schedule for a set of transactions must consist of all instructions of those transactions. It must preserve the order in which the instructions appear in each individual transaction. A transaction that successfully completes its execution will have a commit statement at the end of the transaction. By default, transaction is assumed to execute commit instruction as its last step. A transaction that fails to successfully complete its execution will have an abort instruction as the last statement. Next, we'll move on with conflict non-conflict schedule. Two operations in a given schedule are set to conflict if they satisfy all the following three conditions. The first condition is that the two operations belong to two different transactions given in the schedule. And the second one is that this operations access the common data item termed as X. And the last condition is that among the operations, one of the operations should be a write operation on the same data item X. If all these three conditions satisfy together, then the transaction is said to be as conflict transaction or conflict schedule. If two operations are conflicting, changing the order of execution will produce a different result. Since it is conflicting, automatically the result of the entire schedule will be varying if we change the order of the conflicting operation. There are three kind of conflicts. First one is read write, second one is write read, third one is write write conflict. So first we'll discuss about read write conflict. A read write conflict occurs in a schedule when a transaction write the data which is read by another transaction before it is committing. That is, it will be in the order of read followed by a write where the read is already not committed. Let us consider an example here where the schedule has two transactions T1 and T2. Here T1 has already performed a read operation which is being written by T2, but the T1 has not yet committed the transaction. Since it is of the order read followed by a write operation, it is said to be as a read write schedule. Next we'll move on with write read conflict. Write read conflict in a schedule occurs when a transaction reads the data which is written by another transaction before it is committing. That is, it will be of the order write followed by a read of the same data item. Let us consider an example schedule where it has two transactions T1 and T2 namely. In the given schedule, T1 is writing the data item X followed by T2 is reading a data item X. But whereas T1 has not yet committed the write of X. So here write is followed by a read where the write is not yet committed. Hence this is an example for write read conflict schedule. Next we'll move on with write write conflict. A write write conflict schedule occurs when a transaction writes the data item which is written by another transaction and it is not committed. That is, it will be in the order of write of same data item followed by write of the same data item by two different transactions. Let us consider an example here where the schedule has two transactions, namely T1 and T2. T1 first performs a write operation of X, but it is still not committed. After the write of T1, again T2 is performing a write operation of the same data item X, but still T1 has not committed the transaction. So this will be a write followed by write of same data item X, so which is said to be as a write write schedule. Next we'll move on with a serial non-serial schedule. A schedule S is serial if for every transaction T participating in the schedule, if all the operations of T are executed consecutively in the schedule. Otherwise, the schedule is said to be as non-serial. So to be a schedule in serial, only one transaction at a time will be active and all other transactions will be passive. The commit of the active transaction initiates the execution of next transaction. If in case the transaction is not successful, the abort of the transaction will initiate the execution of the next transaction. Let us move on with an example. Let us consider an example schedule here which has two transactions, namely T1 and T2. So T1 is trying to access the item X, and it is decreasing the value of X by 100, and it is writing back. Similarly, it is increasing the value of 100, that is it is moving an amount of 100 from X to Y. Similarly, T2 is trying to read the value of Y. So here we are able to see that after T1 completes its execution, T2 is performing its execution. So we are able to see here that either T1 is active at a time or T2 is active at a time. So this is an example for serial schedule. Let us consider an example here again with the two transactions T1 and T2. Here we are able to see that first T1 debits an amount 100 from X. On completion of that, T2 increases the amount of X by 100. Here we are able to see that before T1 completes execution, at intermediate state, T2 performs action on the same data item X. So this is an example for non-serial schedule. Next we'll move on with conflict serializable. A schedule is called conflict serializable if the schedule can be transferred into a serial schedule by swapping the non-conflicting operations of that corresponding schedule. Next is conflict equivalent. The concept of conflict equivalent leads to the concept of conflict serializability. Two schedules are said to be conflict equivalent if the order of any two conflicting operations is same in both the schedules. Let us go with recoverable schedule. So a recoverable schedule is one where for each pair of transactions, let us consider it to be as Ti and Tj, such that if Tj reads the data item previously written by Ti, then the commit of Ti appears before the commit of Tj. Let us consider an example here where we have two transactions in the schedule, namely T1 and T2. So T1 first reads the data item X and it writes the data item X. T1 performs the read of X, which is already written by T1. So before T2 commits, T1 is committing its operation. So this is an example for recoverable schedule. That is, even if T2 or T1 fails, any one of the transaction is enough to be rolled back. We need not roll back all the schedule. Here is an example for non-recoverable schedule. Here we are able to see that T2 reads the data item X, which is written by T1. But before T1 is committing, T2 has committed. So this is an example for non-recoverable schedule. Next we'll move on with cascadeless schedule. So a schedule is said to be cascadeless or to avoid cascading rollback if every transaction in the schedule reads only items that are written by the committed transaction. In this case, all items read will not be discarded, so no cascading rollback will occur. If it doesn't follow cascadeless schedule, there is possibility to go with cascading rollback in case of failures. So we'll deal with example. So this is an example for Cascade schedule where we have four transactions. Each of the transaction are reading and writing the data item X. So for example, initially T1 reads the item X and it writes the data item X and it is committing. So T2 is reading the data item X, but which is already written by T1 and it has committed. So even if there is a failure, T1 will not be rolled back. It is enough to roll back T2 alone. Similarly, T3 reads the data item X, which is already committed by T2. Similarly, T4 reads the data item from T3, but it is already committed. So if a transaction is reading the data item which is already committed, it is said to be as cascadeless schedule. Here is an example for cascading schedule. So here again we have four transactions. Each transaction is reading and writing the data item X. So initially T1 has written the data item X, followed by T2 is reading the data item X. But unfortunately T1 has not committed. For example, at the point of T2, if the system is getting failure, both T1 and T2 need to be rolled back. Similarly, if at the end of or after completion of T4, if there is any failure and system is aborting, all the four transactions need to be rolled back. So this is said to be as cascading rollback or cascading schedule. Next, we'll move on with strict schedule. The transaction can neither read nor write an item X until the last transaction that wrote X has committed. That is, every transaction will be reading a data item only from the committed transaction. It will not be reading any data which is uncommitted. Strict schedules simplify the recovery process. It is usually used in recovery process. Let us consider an example here where we have two transactions T1 and T2. So T1 is reading X and similarly writing X. After that, T2 is trying to read the data item X. So before T2 was reading the data item X, T1 is committed. Or in other words, T2 will be reading the data item that is already committed by T1. So this is an example for strict schedule. Thank you.